Well, welcome. We have Chris Sosa, the Director of Engineering here at AMD. What a pleasure.
Thank you.
Great to have you at Infra AI 2025, and we're going to talk a little bit about scaling AI, and we are at the right place, right? What are the workloads looking like today?
They're looking faster and faster. We're really getting more and more out of these machines, and it's really helping us move faster.
What are the challenges, the bottlenecks that AMD is trying to plow through?
So one of the biggest set of challenges is really about maximizing utilization. So especially if you're looking at building any kind of sort of set of machines at scale, you can optimize for a single machine, but once you have many machines, you have a lot of problems. So a lot of those problems deal with people, right? So for example, if you're building a developer platform and you have a bunch of folks who are optimizing and tuning for different types of workloads to run on a platform, how do you actually get them to only make sure they're leveraging the GPU? So for example, are they downloading a bunch of artifacts before they run them? How much of the time are they consumed downloading artifacts versus actually using the GPU? Because effectively, any time you have a workload that isn't consuming the GPU, you're actually wasting money, right? Because these things are expensive, and you want to really optimize your what you paid for.
So how do you keep streamlining the process and keep it efficient?
It's a mix, right? So there's a lot of technologies in the larger ecosystem that we really do rely upon. We make it easy to leverage Kubernetes, leverage Slurm. Those are very common ways to do workload orchestration, but they're not enough. On top of that, you have to build dashboards for tracking utilization. That way, if you have specific teams who are leveraging the GPUs in very inefficient ways, you can go chase them, because that's actually pretty. That's the human aspect. Hey, you don't control all the workloads. You have workloads that get put into the platform. You have to figure out how to maximize it.
So finding native requirements along the way?
Yeah, so there's a lot of native requirements. Storage is one of the big ones that you really have to solve for, and you have to solve for in a way that's, especially at scale, that's more cloud native, right? So especially for low-level engineers who are used to optimizing and tuning workloads on a single machine, the concept of not being able to SSH into your machine is actually fairly challenging to grok. And so when you're trying to actually leverage a larger platform, you have to, at one point, try to meet developers where they are and try to make it as easy for them to consume, but you need to do it in a way that you actually optimize the utilization of all of the GPUs that they have available to them.
So it's constant balance, power, performance, efficiency,
exactly.
At scale.
Yes, at scale.
In a competitive marketplace.
Exactly.
All right, so that's an easy job.
Yeah, all right. and doing it, as fast as possible, because the second, you're building a platform and your CTO gives you 100 machines, they expect you to be using all of it immediately.
Wow. Fun.
Yeah.
So biggest challenge looking forward next 12 months?
I think the biggest challenge continues to be probably a combination of how do you do distributed inference and training really well, combined with how do you do that with heterogeneous workloads. Because it's one problem to if you have one type of workload and you just do distributed inference leveraging 20 servers with 8 GPUs, right? The powers of 2, so 32 with 128. But doing that when you're not the only workload running, you have multiple distributed inference, and the distributed inference is for 2 different stacks. How do you do smarter orchestration to actually optimize how those are placed, how those work well, while trying to optimize for GPU utilization?
And what's next for our ROCm and Instinct development?
So for ROCm, one of the big things that's actually really exciting that we're doing is, we're really trying to meet developers. Developers are a huge part of what makes AMD successful. And then we're not talking about internal AMD developers, we're talking about people contributing to PyTorch, contributing to a lot of the inference stacks that you really need to actually run your models, both to train your models and run your models. And what we're really trying to do with ROCm is make it really easy for everyone to effectively access our AI stack. And one key part of that is making it so that the GPU that you have, whether you have a Windows machine and maybe a 3-year-old Radeon chip, if you can use that to leverage our AI stack, the better. So we're really trying to empower that. Our goal is to really move back and actually be able to support the last 10 years with the ROCm stack.
Nice.
And make it really easy for, if there are any things where hey, this doesn't quite work from a 9 years ago Radeon chip, hey, if I'm someone who wants to fix that and help AMD, it's really easy to do that.
Great. So biggest opportunity next 12 months?
I think, honestly, it's a little hard to say. I think There's a mix of really kind of optimizing for the machines you have. Like I think that, I would say like the growth in models and like, actually, let me take this back.
Yeah.
I don't know the answer to this question.
Okay. Well, it's a hard one, and I don't want to put you on the spot because
Yeah.
you're a public company and all. But from the standpoint of what has you most excited for the next 12 months? How about that question? I'll re-ask it too. Is that okay?
Yes, I think that's good.
Okay. So what has you most excited looking forward the next 12 months?
I think those 12 months, I think kind of like definitely the smarter workload orchestration, like that's a huge component of it, but also making it easier to compose these platforms that work really well for training and inference. Because one of the things we're seeing with building a lot of these platforms is like, for example, Slurm works really well for training. And we see a lot of the different training stacks actually work really well for Slurm. But when you're developing a platform for production workloads and you're running inference, Kubernetes is actually a really good solution, or something more bespoke than that. Seeing more of a convergence about being able to leverage these stacks together as part of one platform, like I'm really excited by that because it makes it really easy to build these platforms and really optimize on not two different platforms you have to build, but sort of one platform that you're really optimizing for driving the overall utilization up.
Well, that's great. Chris, thanks for sharing this insight, and really appreciate you stopping by.
Thank you very much. Thank you for having me.